Hello everyone, this is Pancakes team. We're having our Smart Attendance project here, and I'll be the instructor with this ID, and we're having another two students with two separate IDs. So we'll start the session when the instructor enters. The session starts. The session duration will be 1 minute.
And the first student will enter.
This LCD is responsible for the attending students, so we have one inside the class.
The second student will enter right now.
So we're having total 2 in the class right now.
So to keep track of our attendance, student 2 will leave the room right now.
And the attending people is decremented to 1.
So we're basically waiting for
the 1 minute just to go here.
So
we submit the attendance 75% from the class, and we're having our class for 1 minute.
So the second student will enter right now.
And the instructor will finish the session. So here the CSV file, we just kept track of the attendance student. So we're having final number of attended students is 1, and the session time was 1 minute, the same as we have. And whenever the instructor enters, we have the ID here. You will find that the student entered. This is for the student, and the instructor entered. Whenever the instructor enters, the time just starts, and we have the time for 1 minute. That's why we have the session time 1 minute. And whenever the instructor just goes out, so we have that the session ended. So here's an exit for the final attended students' IDs. Thank you very much. Hello everybody, this is Saif Munsaf from Team Pancakes. I was responsible for the LCD connection. The LCD works in our project for counting the number of attending students. However, if the instructor entered, the session time starts, but the number of attending students still 0. Like here the instructor entered, the attending number is still 0. So whenever the RFID reads an ID, the attending number increments, else it will decrement the number of attending students. The attending number incremented, here another student. And whenever we have another ID, it decrements. Other student. So we use the light crystal library that includes the LCD method, which is responsible to set the register. We have the RS, register select, the enable, and the output pins. Here are connected on this side. So they are responsible for rendering them on the screen by using the set cursor method for the positioning on the screen. That's all. Thank you.
From Pancakes team, I was responsible for the RTC connection. This is the RTC. It is connected by 4 wires: VCC, ground, SCL, and SDA. It is used for tracking real-time clock to determine time of students or instructor entering and exiting. Also, I was responsible for a two LED connection. The red LED and the blue LED, which simulates the door opening and closing. Red LED simulates that the door is closed, and blue LED simulates that the door is opened. This is how the door opens. Moreover, I was responsible for a buzzer connection. This is the buzzer, which works in 2 cases: if there is fire or a card is scanned by the RFID. This is the sound of the buzzer.
My name is Ali Ahmed from Team Pancakes. My part in the project was to integrate the RFID through the Arduino pins. It's connected to the 3.3 voltage, and the rest of its pins is connected to the digital pins of Arduino from 9 to 12. The idea behind the RFID is simple. The reader works as a transmitter and receiver. It sends a signal to the tag and receives its ID. Simply, this is a card for the student. In the code, we handle to differentiate between the instructor ID and the student ID in order to save the attendance record correctly. At the end of the session, we save the file. We save the attendance in a CSV file in order to save the attendance record to be on the database of the university.
My name name is Anas from Team Pancakes, and I will be explaining the connection of the smoke sensor. Let's see here. So basically we have three wires: VCC wire, this wire, and a ground wire, and an analog wire connected to A5 and the Arduino pin. We initially assign an input to the smoke threshold. If the smoke analog read is bigger than the threshold, the door will open automatically and the buzzer will beep. So since we don't have smoke here, we're going to inverse the condition of the smoke sensor, so the doors will open and the buzzer will beep. So let's see here. So here is the smoke sensor, the analog read smoke sensor, and here is our condition for the buzzer and the LEDs, two doors. And here is our smoke threshold. So let's run. So it's still uploading. As you can see here, the blue LED is for the doors, and the buzzer here is beeping, as you can see. And that's it. Thank you.